Alright, so yesterday we started this project and uh, right about just created an interface and our very first, or yeah, we implemented our first method kind of, and yeah, that's about it. So sorry guys. Ugh. Okay, at least that thing is better than that one yesterday. All right, so it did install the Solidity LSP, so we get some kind of errors. The official Solidity LSP kind of doesn't work with NVIM because it's, or the LSP is kind of strict or something. I don't know. So they are not compatible, and that causes some errors and makes it kind of unusable. And also I tried to get Solhint working with Naladas. That does not work either because Solhint does also have some weird behavior. That makes it kind of incompatible. So basically, it is either it works or yeah, it's kind of weird. It works if you either you configure it to have errors or you configure it only to have warnings. And because if Solhint finds an error, it apparently does put out it prints to standard error, and if it just finds warnings, it prints to standard out. And Nala is apparently, well, at least in its default config, not configured to capture both at the same time, or you need to configure which one to capture and to parse. Yeah. Alright, and this thing here, you probably need to, or apparently you need to configure mappings for that. Yeah, I don't know. Or, well, yeah, we could probably do that, but I think we should just continue working on the contract for now. I'm planning, or the plan is generally to implement the logic of this thing, which is fairly simple. And after that, we can, or after that we can implement, or we should have a look at the LSP and probably the other two, or well, the CI. I want to set up, make kind of an example, or try various things in here. Check out the LSP a little bit more, and have a CI up and running with various security tools in there. So there is like Slither and whatever, and see what they produce. Yeah, that's about it. But first, before we get into any configuration stuff that is kind of annoying, let's just code something. So first, some configuration stuff. Where is the... I thought we defined line length is 80 and tag width is 2. So why does it... why does it indent by 4? See what happens if we do... Okay, I'm too lazy to actually use the formatting. No, okay. Let's try this. It's right there again. Wait, what did it change about up here? Ah, okay. We did have a repository test, right? Change anything here? Foundry, Forge, E. Okay. Where is that document? Wasn't it something like Git Foundry or something? Right, so, format. No. Forge FMT. It's FMT. Config references. Width. Bracket spacing. Okay. That's weird. So if we indent by, or if we say we want 4. Look at the... There's pretty much no change. Comes to this code here. I thought we tested it on here. Oh. What the fuck? Tab width, right? Yeah. Fuck. Okay. Okay. Well, okay, so testing. So we were creating the first method. Let's actually pull it up on the other side here, or put it here. So the first thing we did was we created a token ID from the string that was given to us. We could, I'm not sure if we should to check string for invalid chars. That's one thing we should do probably. So there's no space or some emoji or whatever in there, just plain ASCII and maybe a dash and a point or something, or dot. So SafeMint does create and transfer this token. And we do get the token ID, so we can actually check for the token in the balance of that user. We just call it 1 here. So let's have a address call it Alice. And maybe, I don't know, maybe we need a Bob, right? Say Alice is address 1 2 3 4, and Bob is address 3 5. So let's say Alice deploys this thing. Alice registers the name Hello World. So we assert equal repo.balance of Alice should be 1, right? That works, right? So if we change it to 2, that does fail. Take the 2, it's actually 1. All right. So she actually does have the token afterward. Okay. Next thing we do is we need to somehow, or well, we need to create a struct no, we need a mapping of uint 256. Okay, I completely forgot how do we. Yeah, pretty much have to look up everything. What the fuck? So mapping, we need a mapping, yeah, address to whatever. So we need a mapping from uint to string. And that is it public? No, it's let's say it's private, or do we want that thing to be public? I think it's okay, it's public. It's public. It's public anyway, so whatever. So from UN to string, a group map. Not sure if that is a good name, probably not. And we pretty much want to do the mint last, so because mint does contain or safe mint does contain an external call. The group map at position token ID is equal to group name. So that way we can actually that way we can look up the group name from the token ID. Otherwise, Kachik 2have6 is otherwise a one-way function. So this is the reversal of that. So we probably need that. Other thing, we probably want well, let's have a look at the Open Zeppelin contracts. Open. So, let's open. There is a pieces, access control, utilities, probably, right? We can have enumerations. Sorry. Yeah, enumerations. Collections, innumerable set. If you need to support more powerful collections in native arrays, look at, yeah, or remove elements, constant time, don't allow repeated entries, but they also enumeration, which means you can easily query all stored both on and off chain. So we probably want this map. Oh, okay, we don't get we get bytes. Bytes 32 to bytes 32 map. Does that work for us? So the thing is, I actually want you to be able to get all existing entries. That is impractical on chain anyways. So and I thought we could use this enumerable map here. However, they don't support don't support strings. So there's no way you can enumerate that on chain. You just can. You only can look up this group name here. Or, well, you can only... Basically, what I wanted to have is like a get all groups. And that does not work. Well, for one, because there may be thousands or 100,000 entries in there. That's not gonna work, so you would need some sort of paging, and that is probably too much to handle for on-chain computation. Yes, you save everything, or well, you would have to save everything in an array. What we could do is like have an array of mappings, I guess. Can you do some? Can you even do that? Compile. Test. Types of storage containing nested mappings cannot be assigned to. Oh, so that would be something like token or a group map push. Or, well, no, it's yeah, what you would have to do is like have a struct group entry, and that thing contains a token or a it contains a uint, which is a token ID. And a string that is a name, right? And that has to fall on, right? Don't think we need that. Oh, we don't have to do that. So basically, or well, probably need to would have to do something like this here, and a group or group entry array, which is maybe public group entries, right? So you need to you would have to create a group entries push group entry is it token ID and name. I think just plain old parenthesis, write this, yeah, write that, and map, which is then a let's say and position is entry length, right? And that is position is what? Token ID, right? That would kind of work, right? Wrong. We don't name that is group name. Yeah, that works. Is that worth it? Not sure. So you could, if you have this data structure now, which is kind of like 3 times more expensive, which we don't actually care about it here, because you do this thing here once and never touch that again, because there is no delete or whatever modify for this, so who cares? What you could do now is actually on chain, if we provide the methods for that, query the group entries, and so if we say, okay, give me all the entries from at position 100 and give me a set of 50, so we would just return 50 or we would basically return, what would we return? 50 group entries. Not even sure if we can return that much data, which is probably about pretty much maybe Yeah, I think we should not do that. I think I don't know where. I think we should keep that, just because it's way easier, and you on chain you would not query that information. Wait, would you ask, or would you query that information off chain? And probably would, or well, we can at any point change that, because we're not, as I said, we are not going to touch this part of the code ever again, or the data ever again. There's probably, for off-chain data access, do we need that? But for one, you do have access to the blockchain history, if it exists, still exists. So old events can be removed. So but still, you can. So the thing is, we would also only get the data in temporal order, right? So the way we just did it, since we just appended to an array. And if you, yeah, it doesn't make sense. Let's keep it at this here. We don't, since this is also only a prototype, who cares? So we want to send our, or also emit our event. We did define a event on the interface. So index does have this group created event, right? So we emit our group created. I think we can just access this from here. With our new group ID, so which is the token ID, package name, which is the group, or no, what is it? Sorry, we are looking at the owner group ID group name. Sorry, so the owner is it's sender. Group ID is the token ID, and we do have the, okay, let's see, that compiles, right? So, and we want to catch that, or we want to test the group created. For that, look at the Foundry. Oh, that's not it. We want to look cheat code reference, I think. Insertions? Expect emit, yeah. So we want to check for our event. So it is so we need the repository index, right? The interface, sorry. And so we are in VM expect it. So, and the true, false, and whatever, say we want to check on the topic. So it is we want to check three topics. So true, 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 and false, right? Topic 0 is always checked. Emit the event. We're supposed to see before the end of the current function. Perform the call. And after that, emit the event we expect to see. So we emit I repository index dot group created and we expect Alice. Then we want group ID, which is our token ID, and the group name is name. Okay, that should work, but it doesn't. Remember, group not found or visible. Okay. Are events not visible? Let's see. Where is our solidify example here? Say, do have events here. They're defined within this contract. Would have figured that they are public. Never thought about that. But so can we have structs that are what about enums? Nah. Okay. Not found or not visible. Who created? Bench group created. That's that's pretty much the same thing, right? Yeah. What if we import I index from argument dependent type error member not found visible. Okay, let's check on that. And extract redirected by what you can do. Extract placeholder. Number B. Type. Oh, okay. That is that. Where are the types? Contract types. Contracts provide a way to define thing. Various struct outside a contract allows it to be shared by multiple contracts here. Structs can also be defined inside, which makes them visible only there and in derived contracts. Okay, so if we, yeah, so we need to actually define that thing outside, right? So we can get rid of this here, and if we take all these and push them outside, we do format. Oh, it cannot exist outside, right? Mapping operator, it event. It doesn't make sense that the event, well, the event has to live inside this contract. It can't be outside. Because you actually do not, on chain, you cannot read the event. Huh. But what? Do we need to basically copy that thing? Wait. So save this, run the run the compiler. Then it says line 2710, which is in our test here. That's weird. We have the counter test here. It doesn't have a... That thing doesn't have an event in there. Swipe left, someone said something stupid. Swipe right now, I'm watching what you did. Power down now, Okay. Foundry, Forge, Commit, Event, Test. And those are logs. This is not helpful. Cool. So to check the foundry, that is a yeah, that is basically what I found here. Hell. So I'm wondering, is there an example in here? This data. So contract emitter. Even something. Okay, they redefined this event. Yeah. That was what I was thinking. So we basically basically need to copy the events here, which is not cool actually. So say we put it here, and if we do that, works. Okay. We probably want this here to be true too, because right. So if we change that to Bob here, group created, that is causing an error. Reason log. Yeah, we did not find that. So Alice. Right. Okay. Eh. So to be honest, this is a little bit shitty. What we could do is that might be an idea. So let's say we do create a, or let's say we create another interface I repository index events. right? And we do put these in here. We then take another iRepository index events. iRepository index events here. And we do this. That might work. Oh yeah, that works. Okay. That is better. Okay, so we do move. We've moved our event, we moved the events into a separate interface, and we can, by that, using that, we can then mix them into our contracts in the implementation and in our tests, so we can access them actually. We don't have to redefine them. Yeah, that's bad. I guess, fine. Bit weird, but fine. Yeah. Okay, I'm fine with that. Okay, so we get the group ID, and so this is pretty much it for actual creation of a group, right? Next thing is, how do we add a release? So it's just or a package. So a group, which is our token ID here, this uint256. You can actually say uint. Well, because uint is an alias for uint256. So if so a group contains multiple packages, and a package contains multiple versions, and these versions contain multiple content strings here. So, and if we create a release, we need to create write into a package which somehow exists. So we could basically have a mapping of uint256, which is the token ID, to a mapping of, let's say, string, to a mapping of string to string array, and we call that public Um, don't know. However, I think we want to define some more data on that. So probably need a struct release. So a release does have a version. Do we actually, or well, it has a version. But it does actually have a string content and a nuked flag, which we have not defined yet, but we'll definitely have that. Okay. So we do have a release here. Question is, can we live with that mapping? So again, we cannot find out if or when we cannot list on chain all of our packages and releases. But releases is probably a thing we want to check on, right? Or, well, yeah, we probably... Or, well, or what we actually want is probably get the latest release, right? Probably don't, we on chain we probably don't want to check for a, oh well, we could check for a existing something, but then we want the latest version. That might be an actual use case. That is not possible with that. Let's have a look at this thing. We get length, but we don't get something like first and last because they don't store the order, right? So what we could do is we could have a package, struct package, and that package contains versions, which is an, let's say, a Win256 array. and a version and a mapping from 256 to release. Or let's have string here. What? We're missing the name. Version map. Okay, so so what do we have? We do have, let's say, this is group name. To package name. Sorry. To version. Right? Version. Now we are storing the versions in here. We push them to this array, and we need to get probably the cat check of that and put it in here. And look at the release. There's also a question of how much content can we burn in one go. We might need some sort of staging for that, but that's another thing. So instead we can get rid of this thing here. And put packaging. So that should be it, right? So we map the group name to a package name. And from that package name, we get the versions we are looking for. And we can iterate through the versions and get the individual releases. So this case is, let's get the latest version. Okay. That thing compile. It does not. Recursive type is not allowed. Internal or recursive type is not allowed. That's fine. Yeah, we can. Yeah, right. We cannot return that struct. So, like, a public visibility doesn't make sense here. Right. All right. Okay. So let's get a basic implementation running here. So we require. We might want to put that in a modifier later, but we require balance of, or don't need the balance of, we need, is it what is it? Look, we need to check that the owner of the token ID is actually the message sender. So contracts, token, was it owner of? Right. So we require owner of token ID is message.sender, not owner of group. Okay, so if we are the owner, we are allowed to actually add content to our package, to our package or whatever. So we need to figure out what is a package. So package storage. Package is we need to change the name here to packages. Packages at token ID and the package. Package name, right? We pretty much push version. And also let's change this here to a string. For now, you might want to optimize that, but I think the strings what is stored here is actually the hash of the string. So we might want to optimize it later. So we are going to push the version. If it does not wait. That is a problem. Also, we require that content length is larger than 0. Otherwise, no content provided. Right? So we pretty much need a version, or the release storage. Base is package version map version. So if the release no content, release content length date release, else new release, right? So in case of a new release, we do push the version to the package versions push version and in case there is we need do we even need that case? Not sure. So because we want to add the content, right? Yeah, in case we create we create a new release, we could basically just say release content is content, right? And I think we cannot push multiple values to an array, right? Whoop. Sorry. Move array shift left. Yeah, I think we need to pretty much do this thing here, right? And this is uint right? Index. Get array pop move we have the Solidity docs open. Solidity. Array. Fixed byte arrays. C arrays. Arrays. Push and push value can be a new and push appends zero initialized element and return reference to it. Burp. Okay. Okay. Yeah, for loop looks like that, right? So I is smaller than content length, and I++ not optimized, and we will release content push content I, right? And from here we can emit these updated token ID package name version, and we add the creator, which is message.sender, and we pretty much copy that, release it. Okay, let's see. Does that thing compile? No. Copying nested call data, then storage is not implemented. The old code generator. Oh. Okay. Radar, the old code generator. What happens if we enable when I'm looking for Foundry, we do actually I think we can just forward Foundry Toml. Book config reference, delete compiler, and libraries offline. So if we optimize the defaults, changes compilation pipeline to go through new IR. I mean, they might change that, or it might circumvent the error. But I'm not sure if we can just find it here. Well, at least it does something. Yeah, and that looks way better. Warning, this declaration is the same name, not the declaration. Oh, okay. Which one? Function release? Release, storage, release. Storage, release. And then this obviously breaks. What? Where did it break? 51, 54. 151. All right. Okay, so this might be a problem. So this call here, but actually do get to write the release. Right. Okay, so if we function test release public something, and we want some default package here, or group, or wait, string group, uint 256 group ID, right? Group fold group whatever, and the this don't care about that. It or okay. So we want Alice to create our group And after that, we want, oh, what was the test? Cheat code reference. We want to, I think there's a prank start. Notice, maybe. Looking for assertion? No. I think it's prank start. I'm pretty sure prank start. Right. Run the test here. Where is it? Start prank. Start prank. That's extreme. Start prank. Okay. So if so from now on we're Alice, and Alice wants to create a new package, which, or new, a new release. So we call repo.release group ID. Package name is my package. Version is 1.0. And oh, we need to actually create an array. I think we can't do that. Let's say string memory content, and content push some data, right? And that is content. Okay, that should do it. That should not fail at least, but it does. Member push is not available for string memory outside of storage. Oh. Oh, that's a problem. So if we do that, that does not work, right? Invalid type of argument, invalid implicit conversion from string memory to wait. No, that doesn't make sense. That does not make sense. Okay. Index out of bounds. So if you provide 1, so okay, so it's now invalid implicit convert. The problem is if I don't know, can we even do something like that? This again, push. It does not work. Variable storage pointer type can be accessed without prior assignment. Undefined behavior. Defined behavior. Cheat. Yeah, the problem kind of is that, well, if we do this, this is out of bounds. We cannot push, right? Because that was our original. So push is not available in string outside storage memory. Okay, let's have a look. Dynamic arrays. Arrays can have compile type size or the dynamic size. So written and dynamic. Example array of 5. An array of 5 dynamic arrays of uint. Solidity is always containing 3 elements. Right. 0 based. Okay, for example, if you have a variable array elements can have any type, including mapping or struct. The general restriction for types apply in that mappings can only be stored in the storage data location, and publicly visible functions need parameters that are API types. That problem we had earlier. To mark state of error public. Okay. Missing an array past its end can be used to append new element to the dynamic sized array or push appends to the dynamic sized array can be resized in storage memory. In memory, such arrays can be the size cannot be changed once is allocated. Okay, so that is what we tried. Okay. So what about solidity, fixed size or dynamic array memory? Oh yeah, we did not string on data. Yeah, that should work. Stupid. Let's see. Is that not working? Invalid type. because it's often. Yep. 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 At 0 is low. Okay. Yeah, of course. Yeah, we need to initialize the array. Oh yeah. So we don't have to do that over here with our, where's that, mapping or array? Yeah, we do have our string arrays here inside the struct. But the struct is actually kind of initialized because it exists in storage. So we don't have to do this kind of initialization here. But as we're in memory right now, here, we do have to create the new string array, set the size of this dynamic array, and then we can point to a specific slot in the array and put it in here. Then send the create request. So we pretty much need to, the only way well, we can for now only check the emit event. So let's do that. Expect emit. Again, true, 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 and true. What do we actually, so we do expect the release created. It release created. And we do need the token ID, which is the group ID. The package name is this thing, so let's put that into a string memory. Package name is this. Package name, and we want the string memory version is this thing. Okay. Version. So package name, version, and we do have the message sender. So it's Alice, right? Check that. Okay. Okay, so this basically works. We need to put a to do down here for next time. Do check require function, requires requirements on release. Also to do test release update. and we need to test access release data. Okay. Okay, guys. That's it. I have to leave now. We will continue this thing next time, and yeah, we'll just continue next time. Okay. Thanks for watching, guys. Bye.